All right, so section 6.7 is all about using logarithms and exponents in a different way. Everything else that we've done so far has been basically, here is the log, do something with it. Now we're saying like the opposite. Here's the thing you're supposed to do with it. What was the log that created it? So basically this section is called modeling with logs and exponents. So it's called modeling with logs and exponents, but basically what we're doing is we're writing equations. That's essentially what this section is about, okay? Now there's a couple different things or a couple different ideas that we're gonna go through. And if you decide to look through your book is actually gonna cover a smidge more than I'm going to cover. So if you look in your book, you might see one little spot in there that we actually don't talk about. And that's because I don't really understand why they put it in there. And I don't think the application of it is really that important, okay? So the first thing is, do you remember way back when I taught you how to use your calculator to find equations for quadratics and to find equations for lines using things like linear regression and quadratic regression? Do those words, do you remember the words linear regression, quadratic regression at all? Not really. Okay, so if you remember linear regression, quadratic regression, those popped up when we had a table and you were told to create an equation of a line or create an equation of a quadratic or a parabola or things like that. And what you did is you hit the math bar, the stat button, you went to your list, you edited a list, you put in the numbers into your list, and then you hit the stat button again, arrowed over one time, and then it brought up all of the linear regression, quadratic regression, cubic regression, all of that kind of stuff. So quadratic regression, linear regression, all that does is that would create a line or create an equation, and a lot of times we did this with best fit lines. So we had created a scatter plot, and then you found your best fit line from that scatter plot. All right. Now we're going to do the same kind of thing, except we're going to do this using exponential regression. And if you keep arrowing down here, you're going to see just underneath quartic regression, there is ln regression and exponential regression. Ln regression is log regression, so that's creating an equation with a logarithm. And exponential regression is obviously creating an equation using an exponent. Okay, so the ones that we're probably going to be using a little bit more today are ln regression and exponential regression, because those are finding equations for logs. Okay. Questions that you can see as you look at them right now. All right, so just know where those are. You hit the stat button. Stat button will take you to a list where it asks you to edit. So when you edit, you will type in your X's into L1 and your Y's into L2. You'll hit the stat button one more time, arrow over, and then down a whole bunch of times. And once you go down a whole bunch of times, you will find all of the regressions that you need to find. Okay? So that being said, we had talked about stuff that looked kind of like this, where we had an X chart and a Y chart. And we were given a whole bunch of ordered pairs, and those ordered pairs could have looked something like this. So the X's went negative 2, 0, 2, 4, 6, and then the Y's would look something like this. So my ordered pairs were negative 2, comma 2, 0, comma 0, 2, comma 2, 4, comma 8, 6, comma 18. Now, this is where we talked about something called finding the order differences. First order, second order, third order, fourth order. We went through these things and talked about them. Basically, what we did is we had said that if we find the difference between these two things, so 0 minus 2 is negative 2, 2 minus 0 is 2, 8 minus 2 is 6, and 18 minus 8 is 10. If they were the same after doing this one time, it would have been linear. So this would have been a linear equation. This is not a linear equation because those things are not the same. So these would have to all be the same exact number. Like they would literally have to say the same thing in order to be the same, but they're not. So since they're not, I'm just going to move on to the next one. When you're using order differences, you just use these numbers again and subtract. So 2 minus negative 2 is 4. 6 minus 2 is 4. 10 minus 6 is 4. And now you can obviously see that these are the same thing. So this would be called quadratic. Now, if I was asked to write an equation of this, what I would do is I would type negative 20246 into L1. I would type 202818 into L2. I would hit stat again. I would arrow over. I would go down a whole bunch of times until I find quadratic regression, because this is a quadratic equation. I would hit the enter button and it would give me an equation for a quadratic equation. All right. That was something that we did way, way back in like chapter 2 or chapter 3. So it's been a while since we talked about this, but we went through this a while ago. All right. So this is what we should know already. The thing that we're now introducing is the idea that exponential regression can exist. And basically, this is going to be us using a calculator to find an equation of an exponential equation. All right. So the same thing could happen. We'll be given a chart. We have an XY chart. In that XY chart, you're going to be given a whole bunch of X's and Y's. So negative 2, negative 1, 0, 1, 2, let's go to 3, and then like 0.5, 1, 2, 4, 8, 16. So the first thing to look at, whenever you're doing these types of ideas, like we just did on the last one and this one, make sure that your X values are equally spaced out. If your X values are equally spaced out, then you can do this process that we're doing. If they're not equally spaced out, you're not going to be able to. Okay? So if they're equally spaced out, you can. If they're not, you can't. So like in this, notice how all of the X's increased by 1, right? It'd be okay if they went up by 2. The last example that we just went over, all of the X's went up by 2, right? So this example right here, all the X's went up by 2. Negative 2 to 0 is 2, plus 2, plus 2, plus 2. So as long as they're equally spaced, you can go through this and kind of identify them this way. Now, what you need to look for is, it will ask you the question, is this an exponential equation? Or is this table exponential? What you're looking for is you are looking for something called a common ratio. So you want to see if this thing has a common ratio. And a common ratio means, in order to get from one y to the next y, do I multiply by the same thing throughout the entire table? So what I'm looking at right here is, what do you multiply 0.5 by to get to 1? 2. What do you multiply 1 by to get to 2? And we hopefully can start to see a pattern here that every single one of these is going to give me a common ratio. This means that this is exponential, okay? If all of the things that you multiply by from the first one all the way to the last one are the same thing, then that means that it is exponential, okay? Now, one of the things that I'm going to mention, but I'm not really going to write about, is if you're dividing by a number, so like let's say we went from 10 to 5 to 2.5 to 1.25 and so on. I'm dividing by 2, but that's essentially the same thing as multiplying by 1/2, right? As long as your ratio is consistent from the first to the last, that means that this is exponential. So the question would say something like, is this exponential? We would say, yes, this is exponential, and the common ratio is 2. All right? Now, the next part would probably say something like, find an equation for this. If you're asked to find an equation for this, what you are going to do is you're going to use your calculator. So you're going to go to your calculator, you're going to hit the stat button, you're going to hit the edit button, and you're going to start typing in your information. So this one started with negative 2 for the x's. So I'm going to go negative 2, negative 1, 0, 1, 2, 3. You have to be really careful when you do this, because if you end up making a typo, it's going to throw off your equation. Missing a negative sign, skipping a number, it's going to throw something off. So just be really careful when you're doing this, okay? Then when we go to L2, make sure that all of your values line up. If your values don't line up and your ordered pairs are not in the right spot, it's not going to work. So 0.5, 1, 2, 4, 8, 16. So I've got all of my values that are there. Now, instead of having to use my brain power to figure out the answer to this thing, I'm going to let my calculator figure it out for me, because that's way, way easier. Okay? So I'm going to, again, I've got my list all set up. Everything in my list is correct. I'm going to hit the stat button again. I'm going to arrow over one time, and I'm going to look for exponential regression. I'm going to hit exponential regression. Some of your calculators will ask you what values you want to use. If you want to use L1 or L2, or if you want to use L3 or L4, just make sure that it's in the columns that you put in. When you hit enter, it is going to give you your equation, and that equation is going to be y equals 2 times 2 to the x power. It tells you what A is, it tells you what B is, plug them into the equation. When they're in the equation, you're done. Okay? So we end up getting y equals 2 times 2 to the x power. Do not call this 4 to the x. It's not. Okay? This is not 4 to the x power. And I'm telling you right now, you'll do that. But if you can explain to me why you think your calculator wouldn't just tell you 4 to the x power instead of 2 times 2 to the x power, if you can explain that to me, then we could probably figure out why it's not. But your calculator is not going to give you a long answer that doesn't exist. Your calculator would try to give you the shortest answer possible. All right? Do not multiply this up. It is not 4 to the x power. If you're interested, just test any of the numbers and you'll find out that it's not true. Okay? If you try 4 to the x power, let's try 4 to the 0 power. 4 to the 0 power is 1. 0 is not lined up with 1. So when you're going through these, make sure that you understand that you have an a value and a b value. This thing right here would technically be the parent function. Y equals 2 to the x would be a parent function, and I'm applying a vertical stretch of 2 to that parent function. Okay? That's what's happening. Okay? Any questions that you guys have on this? Yeah.
I just have a question about the stat button. So
Okay.
how do you clear the table?
So if you want to clear the whole table, I don't know if there's an easier way to do it, but the way that I've always done it is if you just go up to L2 and then you hit the clear button and hit enter on L2, it'll get rid of the entire row. The only issue is that if you go up here and you hit, like, I think if you hit the, so if you go up there and accidentally hit the delete button, look at all of my columns right now. Now things are changing and it's going to get bad. Okay. If you end up doing something like that, just reset your calculator and then it'll bring everything back to normal. And then your stat button should be back to normal and everything should be okay. I actually, most of the time when I want to clear something, I just reset my calculator anyway. It's probably faster. All right, now let's say, I know that you all have your calculators all the time. Everybody has their calculator in front of them at every single moment. Let's say you don't. And let's say that you accidentally forget it or something happens and you don't have that in front of you. Let's go through an example of how you could do this by hand just in case. Okay, so let's say that I want to find an equation that goes through. So write an exponential equation. That passes through the points 110 and 3, 40. Now your calculator should be able to do this work for you. Okay, it should be able to do this work for you. But let's say that your calculator dies. Let's say that you forget it. If you are borrowing a calculator from me at this moment, all of my other calculators are gone. This is the one that I have for you. If you forget it on a test, this is what you've got, which means this thing will not be able to figure out the equation for an exponential regression. So if you can't figure out exponential regression by hand, then you're screwed. All right? So the way that you're going to do this, remember, your final equation should be in the form y equals a times b to the x power. You are going to set up two equations using your first ordered pair and your second ordered pair. So you have your first ordered pair and your second ordered pair. I'm going to plug x in for x and I'm going to plug y in for y, and it's going to create a system of equations. All right. So this is going to be equation 1. I'm going to plug 10 in for y, so it's going to be 10 equals a times b to the first power. So there's my x and my y. And then I'm going to create another equation for 2. I'm going to plug in 40 for y, so 40 equals a times b to the third power. And then I've got a system of equations that I can solve. So you've got your x's being, or your y's being plugged into the y spot, and then your x's are being plugged into the power. Now, one thing that I would always suggest is that you solve these things for A. So my tip, if you're doing this by yourself or without a calculator, my tip is to solve for A in the equation with the smaller power. So solve the equation for A that has the smaller power. Which one of these has the smaller power? Equation 1 or equation 2? Equation 1 has a smaller power because it's b to the first power, right? If you do that, you're not going to run into any issues, and it's actually going to be really, really nice. Okay? If you don't do that, if you solve this one, you're going to run into some issues, and it's just going to create a bit of a headache. So equation 1 is the one that I'm going to solve for b, or for A. So equation 1, I'm going to do 10 equals A times b to the first power. I'm going to divide each side by b. So I'm going to get A equals 10 over b. And then this is just like every other equation that you've ever solved using using systems of equations anyway. You plug it back into the original equation, or the other equation, I should say. So this is going to be, keep that other one up there, 40 equals, A is now going to be replaced. So it's going to be 10 over b times b to the third. So just replace 10 over b with A. And then now we can start to simplify things and we can start to see how things work. All right? So when we solve this, we will get 40 equals, I'm just going to multiply across the top, so it's going to be 10b to the third over b. And if I have 3 b's on top and 1 b on the bottom, how many b's are going to be left and where are they going to be? 2 on top, right? So this becomes 40 equals 10b squared. This is why you always want to solve for the smaller power, because then you're going to be left with more b's on top, and it's just going to make your life a little bit easier. It's going to make you have a little bit less work. So this will end up being 4 equals b squared, so then b equals 2. You don't have to do plus or minus here because b always has to be positive. Okay, b always has to be positive. You don't need a minus. So now it's really, really easy to solve for A, right? Because if we take this and plug it in right here, A equals 10 over 2. 10 over 2 is the same thing as 5. So now my equation y equals A times b to the x power. A is 5, b is 2, so y equals 5 times 2 to the x. And again, your calculator will be able to tell you that. This is a just in case moment. Any questions you guys can think of? We're good? All right. So the last thing your book really wants to talk about is it wants to talk about, and if you ever see this, it wants to talk about being able to take a point and applying the natural log to it. So if you ever see something that takes an exponential equation and then it wants you to apply a natural log to the exponential equation, it is going to change the graph to be a perfectly straight line. This is the thing that I don't think is important. I don't think it's going to be something that we need. I don't think it's going to be something that we're going to use. I don't think it's something that can really be applied in any way at all. All right. So if that's not something that can really be applied, I don't think it's a good use of our time to really talk about it. Okay. The only other thing that shows up in this section is really word problems. And word problems work the same way as this, except you just have to figure out what the information actually looks like. Okay? So in most cases with these, they're going to give you a table. They're going to ask you to write an equation. Once they give you a table, you just type the table into your calculator, use the equation, or the regression to create your equation. Once you've created your equation, it's just going to ask you to interpret certain things. Okay? Does anyone have any questions from 6.7? You have all the stuff that you need to be able to solve this. You've got one word problem on your big ideas today and 3 of these other kind of like write equations or find equations using regression. Any questions you guys can think of? All right. So I wanted to give you some time to work on this. You guys now have 15 minutes to work on it.